So here we have adding and subtracting polynomials. Before we even get to that actual working of a problem, I need to go over this topic of like terms. Have you guys ever heard of that? Like terms. Very important in this lesson, because if you don't understand like terms, you cannot understand adding and subtracting polynomials, because you don't know what to add or subtract. So this is key. All right, who remembers what like terms are? Does anyone remember? Margo?
Is it maybe a number with the same variable?
Good. It has the same variable, and then we need to keep this next part, which we didn't talk as much about, but it's still important. Okay, they are terms, like terms, are terms that have the same variables, and then we need to have this next part as our definition of like terms with the same exponents. That's super key. We talked about this last year, and we talked about like terms, and basically it's terms that have the same variable. But have you guys noticed in this chapter you have like x to the fifth, y to the second, z to the third? We didn't have that last year. So now that we have those, we need to expand our definition to cover up same variables with the same exponents. That's super critical, especially today. All right, does anyone know how you actually combine them? How do you add or subtract like terms? Like, what do you actually do with the numbers? Add the what? What part of the number? The value. The numerical part. Okay, I think you guys are getting it. It's you can be combined. I'm going to put here can be combined. Yes. Can be combined by adding the coefficients. The coefficients. And does anyone remember what a coefficient even is? What's a coefficient? What's a coefficient? It's a number. Yeah, and the way to describe it is actually pretty straightforward. Benson?
The big number of, how should I say big number? The number that's like not a fraction before the variable or something.
So it could be a fraction. All it is this. That's it. It's the number in front of a variable. The number in front of a variable. It can be a fraction, decimal, whole, integer. And they're usually, yes, the big number in front. What if a variable does not have a number in front of it? What is the coefficient?
Well, it's 1.
It's 1. It could be positive 1 if there's a positive sign, or negative 1. So you're adding the coefficients, and that's important. Good. Do you add or subtract, when you're combining like terms, do you add or subtract the exponents?
No.
No. Don't combine or make those exponents change. You just deal with the coefficients. Okay. Yes, sir.
So it says the same exponent, so it has to be like x squared and then plus x squared. You
Exactly.
Can't do like x squared plus x cubed.
Very good. If you have 2x squared here, you cannot combine it with 2x cubed because they don't have the same exponents. Good. In fact, I want to make sure that we get like terms so well that we need to go to page 525, and I want us to identify like terms. So on 525, number 10, so I know we're kind of going a little bit ahead, but do you see on number 10, they have 5 terms there? Which one of those are like terms? Group them together, and this is how we do the first group, for example. Let's put 3m and 6m. Are those like terms?
Yeah.
Yep, so that's a group. Is there another group in there? If so, figure it out, write it down, and I'll ask you in just a moment. So 3m and 6m are like terms. They could be combined. And then, are there any other terms that can be combined? Ellie, what do you think?
5n and 8n.
Yeah, 5n and 8n can be combined together. They're like terms. What about that 4mn? Is it like these two? Is it like these two? No, but it has m and n. So can it be kind of both? No. To be like terms, they have to have the same variables with the same exponents. 4mn, you don't have to write this down. It's just its own thing. It cannot be combined with any others. You guys get that a little bit?
Yes.
Okay, try out number, I guess number 11. 11 is good. Identify the like terms on number 11. Don't combine them, just write them down next to each other. What are the like terms in number 11? There may be one or more that are like. Excuse me, two or more that are like. Okay, Lizzie, are there any pairs of like terms? If so, what's one pair or one group?
2x and 4.
Okay, 2x and 4x are like terms. Any other groups? Walker.
Negative 8y squared and 3y squared.
Negative 8y squared and, sorry,
3y squared.
3y squared?
Yes, sir.
Are those like terms?
Squared.
Oh.
Yeah, that's my fault. Mine is.
No, I should have checked it.
No.
Sorry.
No, it's definitely my
That's
fault.
me.
No. It's mine.
What about that, what's the last term? 2z? Where does that go? Does it have a like term in that grouping? Nope, it's on its own. Okay, if you can do number 13, you get like terms. So go ahead and combine 13 into groups of like terms. All right, I have selected my next volunteer. Wyatt, give me a group of like terms in number 13.
3p cubed q, and then 10p cubed q.
All right, that's one group. And is there another group? Eli. Negative, sorry, I wrote it the opposite way, but negative p and negative 2p. Those are two like terms. Okay, any other groupings or any other numbers that should go in one of those groups? Do you get like terms? So that means these two can be combined. These two can be combined. Can these two sums be combined? No. So make sure you are careful with that. Okay, any questions on this? Like terms, are we good? Okay. Let's actually put it into practice. Example number 1. So go back to 523, example number 1. And can somebody do me a big favor? One of the biggest favors you could do for me today. Can you just read for me example number 1 so I have to keep going back and forth? Josh, go ahead. Example 1. And read it for me.
Find 4a squared plus 7a minus 12 in parentheses plus in parentheses negative 9a squared minus 6 plus 2a.
Okay. We're going to work these out two ways. You need to know how to do it the first way and the second way. You got to have both of them. You may prefer one or the other. That's great, but you're definitely going to work them out both ways. The way I'm going to work it out right now, first, is the horizontal method. Okay, you see how they're both back-to-back horizontally? Okay, all you have to do is this. Since they're being added, all you have to do is identify like terms. And what's 4a squared plus negative 9a squared? Negative 5a squared. That's what happens when you combine these two with addition. Is there any like term to positive 7a? James? Good. Positive 2a. What's positive 7a plus 2a? 9a. Positive 9a. Is there any like term to negative 12? Oh, come on, Mr. A. Negative 12 doesn't have a variable and doesn't have an exponent, right? I thought that's where our definition of like terms is. Same variables, same exponents. How can negative 12 and negative 6 be like terms? They don't have a variable.
It's 0. It's
0 x.
Thank you for these new words. How many of you agree that the variable would be an a to the exponent 0? A to the 0, a to the 0. You could have that, and they have the same exponents, the same variables, the same exponents. What's negative 12 plus negative 6? Negative 18. That's your answer. So that would be your answer for that one. That's the horizontal way, because I'll wait for you guys. I don't mind. That's a horizontal way of working it out. We're going to also do it the vertical way, and you have to be able to do it both. Okay, I'm going to have the same problem, but this time I'm going to write it vertically. Okay? So I'm going to put the first one up top, 4a squared plus 7a minus 12. I'm going to add with that the second one. But I'm going to do something here. If you catch it, you can raise your hand and let me know. Negative 9a squared plus 2a minus 6. What did I do differently? Beth? Oh, I'm so sorry. I shouldn't have done that. That's not allowed, is it? Riley, why is that allowed? Why can't I just switch them around? Because of the commutative property. Riley. That's okay. So it's because of the commutative property, and why did I even want to do that? It's because of the columns. Now I have like term columns. What's 4a squared minus 9a squared? Negative 5a squared. Or I could have said it, what's 4a squared plus negative 9a squared? Negative 5a squared. What's 7a plus 2a? 9a. And what's negative 12 plus negative 6? Negative 18. And you get the same answer if you do it correctly. And so horizontal format, vertical format. You guys okay with either one? Hopefully it's not too bad. Hopefully. You guys look very confident. Good. Go to page 525. And I want you to do numbers 14 and 16 and do it in the, wow, they wrote it for you in the vertical format for number 14. So do it that way. And then 16, do it the horizontal way. Okay, as I'm working at number 14, I'm a little bit confused because we didn't do this on the last problem. Did you guys notice that there are two big empty spots in that vertical format? Does anyone know why they would put two big empty spots? Like, yeah, does 3a squared x have a like term? Nope. Does negative 5ax have a like term? Nope. So you leave an empty spot there because you can't combine it with anything else in the other polynomial. But I have a question. See if you guys are thinking. This is actually, we're going to be dividing polynomials in Algebra 2. So this is getting us into Algebra 2 in a couple of years for most of you. There are numbers that should go here or that could go here. What value could go right here that would fit this addition but not change the expression at all? You can't just put 5 here because then that changes the value. But there is something I can put without changing the value. Not just 0. There you go. Plus 0a squared x. This is something you don't have to do in this lesson. But in division of polynomials, if you know that that goes there, that's good for you. What goes up here then? Somebody else raise your hand. Don't just call it out. What would go up here? Yes, Katie? Plus 0ax, because that does not change the value of either polynomial, and then you have your like terms that are added there. So are there a lot of implieds in problems? That means things that are not written but could be written? Yes. And so up to you to find them out. Kendall, what's 5ax squared plus 2ax squared?
7ax squared.
Good, 7ax squared. Beth, what is 3a squared x plus 0a squared x? Good. Vivian, what is 0ax minus 5ax? Negative 5ax. Lisby, what is negative 5x plus 7x? Negative negative 5x plus 7x. Positive 2x. Make sure you get those signs right. I'll keep you straight on those. How many of you got this for 14? Okay, 16. I'm not going to write it up on the board. Who has the answer and wants to share number 16 like here? I think I got it, Mr. A. Beth, what do you get?
I got negative 3x squared plus 6x.
That sounds good, because that's correct. Negative 3x squared plus 6x. How many of you got that for 16? Negative 3x squared plus 6x. Okay, good. And if you haven't gotten there or haven't finished it, it's okay. You can finish that up real quick. Okay. That was pretty easy, wasn't it? It's the first half. I'm glad. I need you to write this down on your paper here. Have you guys heard of additive inverses? This is cool because when I brought it up in the last class, I said, have you guys heard of additive inverses? I heard. So Swivl, you picked it up again. Additive inverse. Yes, it brings a sigh to some people. But it's actually not a bad thing. Let's do a little review of this because we have talked about it before. Does anyone know what the additive inverse of 5 is? What's the additive inverse of 5? Benton? It'd be negative 5. The reason that these two are additive inverses of each other is because what's 5 plus negative 5? 0. All right. What's the additive inverse of negative 3/7? Raise your hand if you know. Raise your hand. Josh? 3/7. And the reason that is because what's negative 3/7 plus 3/7? 0. All right. You guys okay with that? Not too bad. Okay, let's get this one. What's the additive inverse of 2a? Hayes? Negative 2a. Why? What's 2a plus negative 2a? Huh. That's interesting, huh? Okay. Ready for some tough ones? Okay, good. I'll give it to you anyway. 2a minus 3b. Don't say it out loud. Just raise your hand. I might call on you. What's the additive inverse of 2a minus 3b? Anyone want to guess? Kyra, what do you think?
I think
Negative 2a plus 3b. What's 2a minus 3b plus negative 2a plus 3b? So this is the additive inverse of that. Okay. You guys are doing too well here. Try this one out. Negative 9y plus 4x minus 2z. What's the additive inverse of that? Harper, what do you think? Oh, that's it? That's it. Last one here. If you can get this one, you're getting it. Don't worry. I'll give you ones where you don't have any answers. What's 7x cubed plus 12x squared plus 21's additive inverse? Additive inverse. Hayes?
Negative 7x cubed minus 12x squared minus 20.
There you go. Can anyone tell me what the rule is to find an additive inverse?
Oh, sorry.
That's okay. Margo?
It has to be 0.
Oh, when you add them together, you have to get 0. But
Right?
Yep. The sum has to be 0. But how did I go from like here to here? Or so what's that rule? What are you basically doing? Because I'm going to write a word that's going to summarize it. Josh, what do you think?
You multiply each term by
Okay, that's a good way to put it. And I'm going to make it even simpler. Just change the signs of each term, right? What's the sign of 2a? Positive. What is it now? Negative. What's the sign of 3b? Negative. What is it now? Positive. So you know what additive inverse actually is? Opposite. That's all it is. Opposite. It's the opposite of the number they gave you. It's additive inverse. So we're going to culminate to this little last key concept here. You guys okay with this? Huh? Yeah, and what are we going to use when we do subtraction? Additive inverses.
Oh.
Do you guys remember a little thing called stay, change, opposite?
Oh, yeah.
Okay, I have a question here and then we'll get started. Yes, ma'am. Number 16. Do you have it, White? Okay. Example number 2. Can somebody do me the second biggest favor someone could do for me today and read me that problem? Margo?
Okay. Find 6a squared minus AA plus 12b cubed.
Uh-huh.
Minus negative 11a squared plus 6b cubed.
Okay. In all the other problems that we dealt with polynomials today, what sign was here in the middle? Plus. Now we have minus. Okay, one way you can do it, it's not to say it's the only way, but one way is to do that stay, change, opposite. You're like, okay, what does that mean? What happens to this first polynomial? It stays. What happens to that negative or that minus sign? Changes to a plus sign. And then what's the opposite of negative 11a squared plus 6b cubed? So this is your problem. It is. Mr. Rain, this all stayed the same.
Yes.
Good. Stay, change, opposite. Now, if we stay, change, opposite, have we done problems like this already today?
Yes.
Do it. And you could do it also with the vertical format. You just do stay, change, opposite, which is really cool. I like stay, change, opposite. I hope you do too. No, oh my.
Thought you'd stay change opposite today. But if you call now, we'll get double the
I'll give you double the homework.
Oh.
Sorry, I had a fault. You did so well, Josh. I got excited and I just want to give more. Okay, anyway, what's 6a squared plus 11a squared? 17a squared. Is there a like term to negative 8a? Nope. Oh, man. So it's just negative 8a. Is there a like term to 12b cubed? Negative 6b cubed. And what did those two combine to give me? Positive 6b cubed. And before I finish this one up, how many of you got exactly what I put down here? 17a squared minus 8a plus 6b cubed? Did anyone get something a little bit different? Okay, this is what I mean. Maybe some of you on another problem might get this. Is that acceptable? Really? One has these two being subtracted and one has those two being subtracted. Are they really the same? Okay, they are because what property says you're allowed to do that? Commutative. And remember how I try to emphasize we're adding these, so you're allowed to do that. The reason I even bring this up is because tomorrow this is what's going to happen. You're going to have this problem you're going to have this answer on your paper, and I'm going to read this. Should I have to read it again so that you can get yours? Like, do I have to check yours, each one individually? Or can I read this and you can still know that this is correct? Can you do that? Okay, you have to be able to do that because there are a variety of ways you can write those answers. How many of you feel pretty confident with this? Good. I'm glad. Allie?
I know how to do it.
Awesome.
But how does it work?
What?
What do you mean?
It's actually a good question. It is a good question. Okay, do you agree that these three are being added?
Yeah.
Do you agree that these two are being added?
Yeah.
And then they were being subtracted, like this whole thing subtracting that. And do you get state change opposite?
That's where yeah, no.
Okay, that's okay. Really what would happen is this. So if I'm looking at this problem, I could still do it without state change opposite. Watch. What's 6a squared minus negative 11a squared?
17a squared.
It'd be the same thing as if you just did that.
It just made it easier on your eyes.
Yeah, it makes it easier to deal with in your head without having to minus a negative. Ugh. And imagine if this was negative 6a squared minus negative 11. And then it just makes it easier to rewrite. Or maybe not. Or maybe so. Okay, go ahead and do number 18. If you can do number 18 on page 525, you are pretty well set on this lesson.
Take it out.
Excuse me?
Is that our ticket
Yeah, that's your exit ticket.
to get the homework?
Yes, to get your homework sooner than not. The top 20 people the first 20 people who get this right get to have their homework first.
Ooh.
How many?
Where's Owen? We need Owen for it to be 20.
Yes, I can participate. I'll take a spot. Okay, anyway, go ahead and do that one. And when you're done with 18, if you get it, just look at 20. You don't have to do it. Just look at 20 and see if you understand what they're even asking you for. You don't have to do it. Just look at it. Read the problem. So again, read number 20 if you're done with number 18. Like, what? Huh? Read the problem. It might help you out. May not. Should. I love the response. It's like, just start reading it, and you're like, I didn't get that. Read it again. I didn't get that, so read it again. And it does sink in a little bit more, but maybe I'll help you out with that, just because this is kind of cool. I'll tell you why. Number 18. Who wants to share their answer? They're pretty confident it's right. Eli, what'd you get for 18? 5b minus 12ab plus 12a. Okay, if you got something like that, or with the commuted property applying there, you got it right. That's good. Okay, can you guys all look at 20 real quick, and then I'll give you your homework? I'm like looking at that. Wait, what? What's wrong with that triangle? Why doesn't it have that third angle? Okay, listen carefully. The reason I'm even bringing this up is because this is about geometry, and this morning I was tutoring a couple geometry students. And guess what they were doing? This, right here. And I'm like, that looks familiar. So this is what they're asking you for. How many angles are in a triangle, inside a triangle? How many angles? 3. You know what those 3 angles always add up to be, no matter what triangle it is? 180. That's what the first sentence is telling you. The sum of the degree measures of the angles of a triangle is 180. That's all they're saying. It says write a polynomial to represent the measure of the third angle of the triangle at the right. Okay, what you have to do is this. What is 2x plus 1 plus 5x minus 2 plus that third angle going to be? 180. Wait, how did you know? They didn't give you. Because what do all 3 have to add up to be 180? That helps you to solve it. That's all I want to talk about that. Okay, your homework. You've earned it. 21 to 37 odd. 21 to 37 odd. It would be all right if you did the evens and the odds. Page 525. Number 37 looks really familiar. Is number 37 dealing with the angles? What do you think?
No, wait, no. It's the perimeter.
Yeah, so we're dealing with not the angles, but what are the three things that add up to be the perimeter? The sides of it. We're looking at the sides of the triangle. So I'm going to make that a bonus question. I don't want just the answer, Mr. A. The answer is in the back. Oh, look, I got it. It's easy. The answer is with your work. No work, no credit. So make sure that you practice that. You all have to try it. You don't have to get it right, but you all have to try it on number 37. I know, it's cruel. But yeah, I want you to see if you can get it. Maybe you'll be surprised, but think it through, and then it's going to be some bonus, but try it out. Don't leave it blank.
How many bonus points is it?
If you leave it blank, minus 10. That's kind of harsh. Minus 9. Okay. Sorry, guys. Yes, I'm sorry.